Hi everyone, good afternoon. Welcome to our presentation, Heavy Duty Wheel Bearing Replacement, a Technician's Journey. I'm Jason Morgan, editor of Fleet Equipment and a speaker on today's event. I want to note this webinar is sponsored by Bauer Heavy Duty Bearings by NTN. Today we're going to be talking about wheel bearing replacement. You'll learn about sourcing and selecting OEM quality wheel end replacement parts for your applications, what separates quality from economy parts, and including a focus on case-carburization. Real quickly about Fleet Equipment. Fleet Equipment provides information equipment managers need to specify, purchase, maintain equipment assets. We track industry trends, focus on the latest issues, and provide the information that keeps you running productively. Housekeeping out of the way, I'd like to introduce my co-presenter, Divjo Singh. Divjo is an applications engineer for NTN Bearing Corporation of America with an emphasis on heavy-duty truck and automotive aftermarkets. In his role, Divjo assists the product management team with adding products to the BCA and Bauer product lines by conducting market research and through a meticulous process involving engineering validation and testing. He has conducted hundreds of product seminars for end users and distributors. So he is well versed in answering today's questions that we have for him. Divjo, welcome to the presentation.
Thanks for having me. Pleasure to be here.
All right, so we'll get rolling here. I have a bunch of questions that I'm looking to have answered as we go through wheel end and wheel bearing replacements and applications. Let's just start off here with the first question. When it comes time for replacement, right, replacement of heavy-duty wheel end bearings, what are some of the important factors to consider when determining the correct parts for that application?
Okay, so that's a great question to start off with. So there are a number of factors which technicians need to consider when when selecting the bearing. The first one being the application. So in the heavy-duty side, it's mostly decided by the axle type. So for the folks who are light-duty, you may do it more by make, model, year. But on the heavy-duty side, it's mostly axle type, the load capacity, and also, whether you're working with a steer, drive, or trailer axle. So that's how you begin to select the part. Once you have selected a part, the next thing would be to check on what your configuration for your wheel end is. So by that, I mean, if you're working on a conventional setup, the two sets and the locking nut, or if you have a spacer. So once you have that, then we can move on to purchasing the bearings. So make sure that for the bearings that you go to an authorized bearing distributor. So because there's a lot of counterfeit product in the market, so you want to stay away from that and get a quality product. Also, our product is case hardened, so you want to make sure that you get a case hardened product. And while we are talking about case hardened, I also want to make sure that everybody understands that it's recommended to replace the sets and not just the bearing. So I know I've been to a lot of shops and it's very easy to just replace the bearing and not worry about the race, because sometimes it can be a pain to remove the race. But regardless, it's the best practice to remove the race as well as the bearing and replace as a set. The reason for that is, the biggest reason is that, you do not want to mix and match the brands, because every brand has its own sort of like recipe for the internal manufacturing geometry. So, you can have the same bearing on the outside, but, it may not have the same surface finish on the inside, and it can go on and on. So it's always best to, have the same race and the same bearing from the same manufacturer, so that you have the best, the longest lasting bearing set. Also, it also makes sure that, you're not mixing and matching, say, a case-hardened part with a non-case-hardened part. So that's the other good point of replacing the set. And I would also like to add to that when replacing a set, think of the race. The race is actually a cheaper product. So if you already are spending the time to, spending the labor and the money to, replace, fix the wheel end, it might as well just replace the race at the same time, rather than, having the guy go out and, come back in a week or so. Then you have to redo the whole entire job, and, it's going to cost way more. So, yeah, those are, I would say, the most important points for replacing the sets, or selecting the bearings as well. Hope that answers.
Yeah, for sure. And I think, the note about replacing the sets and replacing them with the like models, right? I mean, I think that, it could be easy to slip into a bearing is a bearing, but a bearing isn't a bearing. These are highly engineered and manufactured components that need to pair well together. And you don't want to, as your point, set yourself back by doing something that isn't a maintenance best practice. You mentioned coming back into the shop a week later. Definitely not what you want in that regard either. Something I think you alluded to and touched on here that I kind of want to dive into is case-carburization. What does that mean? Why is it important, and what are the specifics there? Hold on, everyone. I think we have a connection issue here. 1 second, please. Just a quick update. Divjo lost connection. He is connecting again here momentarily. Bear with us, please. Technology is part of the fun. While our presenter is getting reconnected here, recalling in, just kind of want to go back on a few of the points here in terms of some of the points that he mentioned in terms of application, specing the right part, getting the right replacement part. Oh, Divjo, is that you?
Yes, I'm using a different line.
Oh, no problem. Glad to have you back. So I'll repeat the question just so we're on the same page and we can kind of get our bearings here, to pardon the pun. I love the pun, so sorry, I had to use it. When we were talking about product specifics, case-carburization is something that comes up. What does that mean? What is that? And why is case-carburization within bearings so important for the heavy-duty application?
So sorry about that. So as I was talking about earlier, the case-carburization process is basically essentially a heat treat process, and it will basically make a case around the bearing, around the steel, which is the hardness is a lot higher than the core of the part. The core will be a lot softer. It will be a lot more ductile. And the reason we do this, and especially in the heavy-duty trucks, is that the outside shell can take a lot more shock loading. It can take a lot more beating, like especially in the trucks, you get a lot more beating than light-duty vehicles. So that's why case hardening is a lot more important and more critical for the heavy-duty trucks.
Yeah, for sure. Okay, so I've got my product. I got the product I need. I got it spec for my application. I got the OEM quality. I got the case carburization in place, and now I have to install them. Right. So what are the next steps, including maybe different mounting and adjustment options that I need to take into consideration?
So let me get to this slide here, and it talks about the typical wheel and bearing components. So to talk about the assembly, we have to first know what the components of the hub are. So in a typical wheel bearing set, you'll have two wheel bearing sets: the outer bearing set and the inner bearing set. Typically, the outer bearing set will be the smaller of the two sets, and these sets are inside the hub assembly, and they are mounted onto the spindle using some kind of locking mechanism. So speaking of locking mechanisms, there can be so there's the conventional double nut system, which is very popular and it's been used for a very long time. And there's also the more recent single nut systems, which only have a single nut versus two nuts. So the installation will kind of vary depending on what system you're using. But regardless, there are a couple of things which you need to be aware of or be careful while installing. So basically, in every installation, you have to do like a pre-installation or like a pre-check. Make sure when you take out the hubs that the inside of the hubs are clean. There's no burrs or nicks on the shaft or the spindle. Because in case there's any kind of nicks or burrs on the shaft, it may lead to, like as you can see on the picture, for example, if we do not clean the shaft properly, it's going to lead to the bearing will not, sit flush with the shaft, and it may lead to misalignment. Misalignment is actually one of the failure modes on the bearing, so you may not see the full life of the product. So that's why checking the shaft, checking the spindle, checking the housing, making sure everything is correct, that's the first step. From then, the second step would be to remove the old races. So that will kind of depend on what you're working with, if you have an aluminum hub or a steel hub. Steel is a lot more forgiving than aluminum. So with a steel hub, you can just like basically pound the old races out, using some sort of tool. With aluminums, you got to be a little bit more careful because aluminum is a softer metal. So, you don't want to like, really bang the, you don't want to really like bang the metal, so it might deform and, it may get out of round. So that could be really bad for the bearing life. So be careful with the aluminums. A good trick I learned at the shops was that, a good way, easy way to remove an a race from an aluminum hub would be to weld a bead around the aluminum, and, that's going to just make it, it's going to shrink and it's just going to drop from there. So that's one way. And also, and one more way would be to basically heat up the hub. That's the other way too. That's what I was trying to allude to when I was talking about the different ways to remove the races. Once you have removed the races, then it's time to put the new races back in. So again, if it's aluminum, just be more careful while putting the races in. And this time, we also want you to be more careful. Make sure that you're not hitting the race directly. You always want to have some sort of like a buffer, like, some like maybe a plate or like a pressing tool, something, so that, you don't hit the race directly. Because what can happen is, for example, if your tool were to hit the race directly, it can, create a mark, create a nick in there, and then that can lead to a reduction in bearing life. So make sure that you use the proper tools. And another trick I have come across is sometimes it's easier to just freeze the races. Just freeze the races in the freezer overnight or something, and make sure that you wipe the condensation off. Because that's not good for. That's bad for corrosions. So once you do that, those are some of the most most common steps, or the best tips I could give you for installation. Moving on to a little bit more detail on that. So basically, if you are using a conventional setup, so this is what I was talking about earlier with the double nut system. So if you're using a conventional setup, typically you will use a RP618. So this is a procedure which is developed by TNC, which is the trucking maintenance council. So they make all of these procedures for safety and engineering. And the whole purpose of this procedure is to install the wheel bearings properly. And by properly, I mean that, once they're installed, they should fall within a certain end play. And the recommended end play for the truck setup is between 1 and 5/1000 of an inch. So that is really small. So that's why it's very important to follow this procedure very carefully. And most of the shops I've been to, they know about the procedure, but sometimes, they may not have the table in front of them. So it's always best to have this table, displayed in the bays. It's an 8-step procedure, as you can see, and it's going to vary depending on what type of nut you have, whether you're working on a steer, drive, or trailer. I'm not going to go into detail of the full steps, but as you can see, it can get a little complicated. So once you do that, make sure that you follow it all the way across to step number 8, which is actually checking the end play. So I've actually been to shops, where they are very, very diligent, they follow the procedure. They're very proud of following the procedure, and they do all the steps correctly. But then they forget to, check the end play. Or if they check the end play, they forget to, write it down. So once you check the end play, always write it down, so that in the future, in case, that 1% chance in case something were to happen, or if there was a wheel off failure or something, then you can always track it back to your work order and see what the end play was recorded at, and that could be that could be a lifesaver sometimes. So moving on. So in the previous slide, I was talking about the conventional setup. So there's also another type of setup which is actually, it's a little recent. So it's the spacer setup. So with the spacers, you will typically have the 2 bearings, as you recall in the previous slides. There was a setup which showed the 2 bearing sets, and so the spacer will basically go in the middle of those two bearings. And the big advantage of using the spacer setup versus the conventional setup, the biggest advantage, what I see is it's saving of time. It saves a lot of time. So instead of that 8-step procedure, you only have just 1 step. So that 1 step being just torquing down, the bearing to just the right spec, and there's no back offs. So in a regular setup, you torque it down, you back it off, then you torque it down again, and then you'll do a final back off. But in the spacer setup, you just torque it down 1 time. There's no back offs. So that's a really huge time saving, for the technician. And the other good thing about that is it's consistent. So you don't have to worry about if your play was in spec or out of spec or what the actual number was. Every time it'll give you a very consistent reading, and you can be it can be considered like a safety thing too. It's so consistent. So the procedure I talked about before, there's actually, of course, if someone wants to actually look at the whole procedure on our website, it's actually one of the links on the webinar. They can go on the website, and there's a full video. It's like a 30-minute video of the full procedure. If someone is interested to watch the full video, it's on the Bauer website.
Okay, very good. Very cool resource to check out afterward as well. I want to take a pause in the questions here just to remind the audience to please keep sending your questions. We've got a good a number of questions here piling up for our Q&A session here. I've got 2 more questions that I definitely want answered. So keep sending your questions in, and we'll be sure to get to them. Use the Ask a Question box, and then click Submit on your screen. Okay, so one of my next questions. So we have the bearings installed. Everything is good. The truck rolls out. You mentioned misalignment as a potential failure mode. I want to kind of just dive into that. What are some of the other failure modes and other causes of wheel bearings to not meet that expected life?
Okay, so that's a very good question too. So to define failure, like let's talk about, well, a precursor to that would be like what's bearing life. So bearing life is, it's in theory, you can define bearing life by calculating, the loads, the speeds, the temperature. So it varies a lot. So there's no like a right answer for a bearing life. But what you want to have is a good bearing life, and you want the bearing to last as long as possible for that application. And that's when we get into bearing failures. So sometimes you'll see bearings are not lasting as long as they should. And there's a multitude of reasons for that. As you can see on this slide, the biggest one I've seen is related to the bearing setting or adjustment. So as you recall, like we talked about the setting, like the TMC setting for the bearing end play is between 1 and 5 thousandths. So if that setting is not correct, you can see failures related to the setting. There's failures related to lubrication and as well as handling, and depending on the application, if it's got a lot of abuse, it could lead to failure as well. And as well as installation related too. So let me get into more detail on this. So as you can see, the bearing, so this failure relates to the bearing adjustment. So in this picture, you can see these are rollers from a taper roller bearing. So as you can see on the roller, on the bottom, which is the larger portion, the larger part of the roller, you'll see flaking on the roller. Flaking means just basically material is coming off from the surface. That's what flaking is. And it's a failure mode. So whenever you see flaking on the larger end, that means that the setting was likely too tight. So that's a giveaway. If you have an improper setting, if it's too tight, it's gonna create a lot of preload, and that preload is gonna heat up the bearing, and that's gonna lead to flaking on the large end of the roller. Now, versus if you had the same kind of flaking failure on the small end, which is the upper. If you look at the picture on like the photo on the left, you see on the top of the roller on the smaller end, you'll see flaking. So if you see flaking on the smaller side, that's more related to the bearing setting being too loose. So these are the 2 most common failures I see. However, there are a few others which I would like to share as well. Overloading. So obviously, if the truck is not being properly loaded, or if it's being abused, you will see, flaking on the race itself, or, it could be on either race. It could be on the inner race, which is the bearing, or it could be on the outer race, which is, we also call it the race. Now, this can also happen, when the bearing reaches its its end of its life. So it could be from overloading, or it could be from just, the bearing just being exhausted and it just needs to be replaced. Another failure mode, this is more related to, not using the proper tools. So as I alluded to earlier when we were talking about the installation, if you recall, I talked about, when you're installing the race in the hub, make sure that you use some kind of some kind of barrier, do not hit the tool directly on the race. So this is what can happen if you use tools for installation. Now, another reason, not very common, but sometimes it can happen if you do not take the full precaution of cleaning the parts before installation. Like let's say there's some kind of nicks or burrs on the shaft or inside the housing, the bearing will not seat fully, and if it's not seated fully, it could lead to misalignment. So if you can look at the picture of the race on the bottom, it's actually the same race. Both pictures are of the same race. The picture on the right is actually the same race, which is flipped around 180. So if you were to look at the the picture on the left on the bottom, you see the frosting, it's across the entire, section of the raceway. But on the right, you see it's not on the entire raceway. You see a shiny portion on the bottom. So that means that the rollers did not fully engage with the race. So that's a good indication of misalignment. So if you have a spare race or a failed race at your shop, feel free to pick it up, and just take a look at it and see if it's from misalignment or not. Another common failure could be from contamination. Now, this is very easy to prevent. Just make sure that you leave the bearings and the races inside the boxes. Do not open the boxes until you're ready to work on the truck. Otherwise, debris can get inside the box, and that debris can get inside the bearing, and it could lead to these small dents on the raceway, and eventually they could lead to a lot of sound, a lot of noise coming from the bearing, and early failure. Make sure that your lubrication that you use is the correct amount, and the whatever the OE recommends, and make sure it's the proper amount. So otherwise, it could lead to overheating and early failure. Some of the other failures can be related to installation or handling. So as you can see on the picture on the right, it's actually a picture of a bearing with a bent cage. So that could have happened from mishandling, or if the bearing fell or something. So in that case, do not reuse the bearing. Our products are not fixable. Now, some of the other less common failure modes. These are on the top left. You see frame. So that's more common, if you were to use in aluminum hubs. So what happens in aluminum hubs is that they tend to go out of round a lot more than a steel hub. So with aluminum hubs, the races might have a tendency to spin or creep inside the housing, and that could lead to this rusty-looking surface on the bearing race. So don't confuse that with rust. It's not rust. It's actually fretting, which is the bearing spinning inside the housing. So that's more common in aluminum, but in steel we do not see that happening. And it's some of the other less common failures, overheating, and on the bottom that's actually a very bad failure, a very bad looking picture. It's spalling. It's a combination of multiple factors, lubrication and excessive loading. So those are the most common failures I see in the trucks. Obviously, there's a lot more failures in the bearing world, but I think I covered those pertaining to the trucks.
Yeah, for sure. And these were wonderful, really cool images and pictures. I just want to remind everyone in the audience, too, that, again, this will be recorded, right? We'll drop you an email after this, too. I mean, it's just a great resource. You can grab your bearing and take a look and see what it matches up to and kind of get an idea of what's going on. Very, very cool. Okay, in that regard, staying on the the bearing life track here, what are some tips for optimizing that life? Like, I want to avoid all these pictures, right? What are some best practices that'll keep me working productively?
So yeah, that's a very simple answer. That one's easy. Just make sure that as long as you're getting a good quality product, good quality bearing, getting it from a authorized dealer, making sure that it's not counterfeit, it's a great, and if it's a high quality product, if it's a case hardened product, so that will make sure that you'll get the highest life out of the bearing. Also, once you have the high quality part in hand, make sure that you install it correctly, you use the proper procedures.
Thank you so much. That was excellent. Lots of great info there. Divjo, really appreciate you taking the time to share that with us. We're going to start getting into our audience question now.
Okay, that sounds great.
All right, so the first question we have revolves around greases. The question is, what type of greases are used, and what are their requirements in terms of temperature and things like that?
So greases, that's a very broad topic. Greases can be, it could be synthetic, non-synthetic, high temp, low temp, there's a lot of different things which go into developing greases. What I can say is just use the grease which the OE recommended. So we do not recommend a particular brand or, any specific grease. We just tell you to use whatever grease that came with that bearing or whatever grease that OE manufacturer recommends. One pointer I can give you is do not mix and match greases. Sometimes they are not compatible. So make sure that the greases, if you were to mix and match, just make sure that they're compatible. Or it's always best to just remove the first grease completely and then put in the new grease to make it a fresh start. So
yeah, for sure. We've talked about that as well at Blade Equipment. It's amazing how the little details play a huge role. So making sure you have the right ones there is definitely important. A pair of questions here from one of our attendees. Do you offer replacement pre-torque bearing sets? And do you have a torque chart for dual wheels and steer wheels for Class 8 trucks?
I'm assuming by pre-torqued, they are referring to the preset, if I'm not mistaken. And if that's the case, if they're talking about the preset bearings, then yes, we do offer preset bearings. And in fact, there should be a link on the webinar to go to our Bauer landing page, and it'll take you to the preset page as well. And actually we have launched the preset spacer kits as well. So those will be the spacers, and then they will come with the preset bearings. So there will be two sets. So you will have the two preset bearing sets and the spacer in that kit.
Okay, very good. And then the second part of the question of torque charts for dual wheels and steer wheels, Class 8 trucks. Do we have that torque chart available?
TMC publishes the torque specs on their chart. So it's actually on their RP618B table. So if they can, it's on their site. So you can go on their site and download that table. It has all the torque specs for the conventional type nuts.
Okay, perfect. Yes, excellent, TMC. Always a great resource. In terms of the bearings themselves, are the bearings fabricated on an international standard?
I'm sorry, can you please repeat that question?
Yeah, the question was, are bearings fabricated on an international standard?
Yes, they are. So the ISO standard, yes. So all the bearings are made to the dimensions, the external dimensions are made to the ISO standard. Yes, that is correct.
Okay, and then go ahead.
I actually wanted to tell you on the previous question, someone was asking about the torque specs. So we actually also have that table available on our site as well.
Okay, excellent. So the website links that we were sending around here in the webinar as well, you can find that information there.
Yes.
Follow up in terms of the bearing manufacturer, are they made in the USA?
Yeah, so all of our Bauer product is made in the USA. We have there's 2 plants, Macomb, Illinois, and Hamilton, Alabama, and they make case hardened product. Okay,
very good. I got a question diving in here to some of the maintenance that you had mentioned. The question is, what do I do if I lost the spacer? Can I get a new one if it was damaged?
So with a spacer, the kits, so if you were to purchase a new kit, they will come with a spacer. The spacers do not come loose; they come with a kit. So someone will have to either purchase the whole kit, but if they were in a crunch and they wanted to use the preset bearings, they could just use the preset bearings by themselves and without the spacer, and just follow the conventional RP618, the 8-step procedure, and they should still be fine with that.
Okay, perfect. Question here, a bit of a broad question. I think we touched on it here already. The question is, what is the lifetime of bearings? I know that's a broad question, maybe in terms of even application. Any kind of insight you can provide there in terms of estimating lifetime?
That's a very broad question. In fact, there's no like, I don't have a right or wrong answer. It all depends. It varies, depending on if the application, how abusive the application is, if it's an off-road application or if it's an on-highway application, if it's, running below freezing or if it's, in running in a desert somewhere. So it's got a lot of variables. We cannot really determine exactly how long the bearing will last.
Mm-hmm. Mm-hmm. And even how long or how often should these components be checked? How often are you looking at the wheel ends and preventative maintenance just to make sure you're getting your life out of them? How often should you be looking at them?
So for the PMs, I would say that for every check, I would say that at least check the bearings, make sure that the lubrication looks okay, make sure that the seals are not leaking. Just do a general checkup, and if you think that the bearings need to be replaced, make sure that you replace the whole set, the bearing as well as the race, and also make sure to replace both of the sets in the same in the same hub.
Right, for sure. It helps maintain the uptime and kind of keep an eye on those lifetime expectations even for your own application too. Another question here from the audience. Lots of good questions coming on from the audience. Keep them coming. We'll go to the end of our time here. Kind of an observation here from an attendee. It says the new sealed bearing feels rough when you spin it by hand. They've seen this numerous times. This was a front wheel drive vehicle. Any thoughts there as to why that might be the experience or what kind of impressions they're getting from that?
If it's a new setup, so if they're talking about a new hub assembly which has a new seal, new bearings, new grease, and everything is new, that could just be from just breaking in. So it's gonna feel like that maybe for a few rotations, and then once it's broken into, it'll just work fine.
Okay, very good. Going back, I know we talked about preset bearings here a minute ago, but we had a follow-up with that. Are the preset bearings sealed?
No, they're not sealed. So actually, none of the sets are sealed. The wheel seal, which I was talking about earlier, it's actually a different it's a different part. So you have the inner bearing set, the outer bearing set, and the wheel seal goes behind the inner bearing. It's a different product. It's not a part of the wheel bearing.
Okay, very good. Another question here, lots of good questions coming in. On the spacer bearing, are those preloaded specs, and how do you adjust it?
So on the spacer bearing, that's a great question. It's actually a little different than the conventional setup. So if you recall, in the conventional setup, you have this 8-step process, versus for the spacer setup, you only have basically, once you are done installing the bearings and the spacer, you only have to install the nut and just torque it one time. There are no backoffs. So that's the biggest difference. And for the actual torque spec values, those will be, those can vary depending on the manufacturer of that nut. So, once you have that nut in hand, it'll have some kind of instructions in there, and it'll tell you exactly what the torque specs for that nut are.
Okay, very good. Do you have spacers available for TRBs, and can you share any information about that?
I don't think I understand. So by TRBs, I'm assuming they're referring to taper roller bearings, right? So yes, we do make spacers for taper roller bearings. I think they're the same preset kits which I was referring to earlier, and these are also on our link. So if they follow to the Bauer landing page, we will have the link to the Bauer preset bearing kits. Okay.
Okay, perfect. Okay, so how about tech support, right? If there's a bearing failure, I have bearing problems. What kind of support do you offer your customers in the industry?
So we have a hotline. They can call us anytime. It's on our website as well, that number. Also, we do offer clinics. We can go to the techs and actually demonstrate the procedure to properly install the wheel bearings. We also have a lot of resources on our website which have a lot of tech tips in there, as well as the video. If someone just wants to watch the video, there's a 30-minute video on our website which talks about the proper installation and the best practices.
Okay, very good. Sorry, just keeping up with the questions here. We're getting a lot of great ones here toward the end.
Sure, no problem.
Okay, so here's one. What is the best way to clean a bearing when repacking?
The best way to clean a bearing when repacking, there's no right or wrong answer to that. Just follow the OE procedure for that, because we do not recommend a specific grease to be used. Just use whatever grease which came with which the OE recommends. And the best way to pack it is, we do not want you to really fully pack the bearing. We just want the bearing to have at least some kind of lubrication. So just get a shop rag, put some lubrication on it, and just rub it all the way across on the bearings, and should be good to go from there.
Okay, very good. Have a couple of, we're going back to the spacer questions here. Got a couple of those following up from our conversation here. This question says, all hubs have tolerances. How does the spacer bearing set ensure proper bearing preload?
Okay, so that's a great question. So the spacer set, as you know, it comes with the two bearing sets. So there's a spacer, then you have the two bearing sets. The sets in those bearings are actually preset, what we call preset bearing sets. and they already have, so the tolerance on those preset bearing sets are, a lot, I would say 70% tighter than a standard set. So by using those tighter tolerance bearings and with the very tightly controlled tolerance spacer, you're able to get that, the end play setting, just with one, with just one torque, and you can just get the end play without having to go through the procedure, the 8-step procedure. Hope that answers that question.
Yeah, and maybe for sure, and this one's follow-up, maybe related, and maybe just you could reiterate here. But this question was, is the spacer, is it like a crush sleeve? Is it a one torque application? Did that last answer covered, or any additional insight there?
So it's actually it's recommended to replace the spacer every time. It's recommended by the manufacturer to replace the spacer, but sometimes, once you take it out, what you have to do is check on the ends and see if it's got any kind of like wear on the ends. If it's got any kind of wear on the ends, then definitely you have to replace it. It's not a crush sleeve.
Right. No. Okay. Very good. Sorry. Really good questions here. So I'm just keeping up with them. Let's talk about the seals. Do the wheel seals always need to be replaced? And do the seals vary by application or mounting type?
I would say best practice would be to replace it all the time. And, they do vary by, application.
For sure. Okay. Let me see here. Torque spec on axle bolts. The question is, what is that torque spec on the axle bolts?
I'm assuming they're referring to the torque specs when they torque down the nuts on the wheel ends, and those torque specs are in the RP618B procedure by TMC, and we have the table listed with all the torque specs on our landing page. So there's a link on the webinar for that. They can go to and check out the actual specs.
Yep, definitely. I know we've referenced that chart and that table a number of times. So definitely, attendees, a good note to make when you get the follow-up email for the recorded interview, or you can click the link and go check it out now. Okay, back to a cleaning question. The question is, can you clean a bearing with mineral spirits of diesel and then blow dry?
I would not say I've not seen that happen. I've seen that happen, but it's best practice to just just clean it, make sure that it's fully clean, and you could use some kind of mineral oil that would be good to clean the bearing with. Okay,
maintenance-related question here. How can I measure the lubricating film on the bearing?
So that's not a very common question. As long as so all you need is a little bit, like a slight, like very light amount of film on the rollers. You do not need to, really pack the bearings with grease. All they need is some kind of way to, prevent metal-to-metal contact. So all you need is a little bit of lubrication. So just take a finger, put some lubrication on it, and wipe it around the bearing on the races, and make sure that it's got film all the way across. That's all you need.
Mm-hmm.
Hey, Bill, can you hear me?
Very good. Kind of a cool international question here. The question is that we've mentioned made in the USA. But do you only offer wheel bearings for trucks of American manufacturers? Any international lines or distribution there?
No, we offer all kinds of bearings for trucks, and as well as we also offer wheel bearings for cars and light duty trucks as well.
Okay. Very good. Okay. Very good. I think that answers a lot of our great questions today. I want to thank everyone. Divjo, you are a superstar with our lightning round there. We got a ton of questions. Any questions no problem. Appreciate you taking the time and sharing your expertise there. Any questions we might not be able to have gotten here during our time in the webinar, we can follow up with after the webinar, after we conclude here. And that's all I have. Divjo, again, thank you so much for taking the time. Everyone, thanks for attending on the attendee side, and everyone have a great day.
Thanks for having me.